Welcome back. Today we're going to be looking at queuing in Python. So a queue, as you can imagine, is a lot like a queue. The person who goes in first is the person who comes out first. And obviously if we're different, so you get in the queue and then they pick random people, that wouldn't be fair. And it turns out you can do the same thing with queues in Python. So the queue module has a multi-producer, multi-consumer queue. And this is useful for threading because you can transfer data between threads really easily. And they've implemented all the locking that's required for using queues with threads, which makes it so much easier to use. But first we have to understand what a queue is. So you have two main things. You can put or unqueue, and you can see if this is your current queue, where you've got the front and the rear, you're just adding something to the rear of the queue. And then you've got a get, which is basically where you take the thing off the front and you're left with this. And these operations are fairly simple and they make a lot of sense. If it's a queue, you take from the front and put in at the back. But there are a couple of other methods. First one is queue size, which gives you the approximate size of the queue. And this is because between operations it might change slightly, which is why it's only an approximate size, but most of the time this is going to be spot on. And empty will just tell you if it's empty or not. So first we should have a look at the simple queue. First we're going to look at the simple queue, which is like a queue, but it has none of the threading functionality, which makes it a bit easier to use. So we're going to say from queue import simple queue, and make sure that if your thing is called queue, you don't name it that, because it means it's going to try and import queue from the current Python file. So it's okay here that this has got a capital Q even though this is lowercase. So we're going to just define our simple queue. So say Q is our simple queue. So we can then just put some things in. So we can put in 5, put in true, put in A, because queues take anything, and then we can say, and then we can just print q.get, and we can do this 3 times. And you can see they've come out in the order they've gone in, which is unsurprising because that's what it's meant to do. But obviously we could make this more impressive. So we could say while not q.empty, print q.get. And maybe here we have a list of things that we want to add. So we'll say items are A5 true, and then we can say for item in items q.put item, and it finishes. And you might say this is a trivial example. We're basically taking a list and converting it into a queue. But if we're going through the list and we want to add to this queue, then we can just append an item, but we still have to keep track of where the start is. And you also can't change the size of iterables when you're iterating through them. So actually a queue does have these advantages, and as I said, it's mostly best with threads. But one thing I want to look at is what happens if we don't have this q.empty line in here. We just say while true. And you can see here, it just waits. And it's expecting something to put it in, even though there's not going to be anything. And it's not even listening for a keyboard interrupt, so I'm going to have to kill this window and reopen it. So instead what we can say is we can have a timeout, and we can say that if after 1 second nothing is there, then we've got an error. And so we wait 1 second and we get this q.empty error. And the reason is because it's raising this empty error. So then we can say while true, we can try this, and if it fails because it's empty, we can print Q is empty. And you can see that works. And you might say, why is this better than using this queue.empty? And the answer is the queue.empty isn't always perfect. And it also means we can have these timeouts in here, which are very useful. And if we're using multiple threads, which we'll have a look at, you'll be able to see how we can put stuff into our queue. So next we're going to have a look at this queue and do some things asynchronously. So I'm actually just going to copy all of this code and put it into here, except that this is going to be a queue and this is going to be a queue. I'm also going to import time so we can wait, and from threading I'm going to import thread because it's based on using threading, so we'll need some threads. So what we'll have is we'll have a function. So this function will be called add, and it'll have some items, and you see there are some items there, and quite simply we'll just put items into the queue. So what we can do is we can say we have a thread, the target is add, the args are items, and so maybe we should make this start items. And of course we want to start this queue. And you see that this does exactly the same thing. But then if we change this so that we then sleep for 1 second and set the timeout here to 2 seconds, then we've now got stuff being added every second, but we're waiting 2 seconds to see if it's gone. So now you can see it's printing it out with that delay in, because it's waiting in this thread before adding each item. And then when it's finally empty, it will wait. And if we use the queue.empty, then we wouldn't be able to have this timeout. We could also have multiple threads, so we could have another set of items. So maybe we want to put in an orange, an apple, and a banana, make things a bit more fruity. To our add items, and maybe here we'll change this so that it's a random amount of time. So so now it's going to sleep a random amount of time between 0 and 1, and then it's going to wait and check if the queue is empty. And you can see it's gone through all of them, and at the end decided the queue is empty. And you might think, where does this have applications? And one really great application of this particular queuing is where you have some threads trying to process a video, and you've got one thread displaying the video, and so you just put all the frames in the queue with the correct order, and each time you update them, and then you display the threads as they appear. However, it turns out that there's actually a better way of doing this, and here what we do is we can say that when we add the item, we can set the timeout equal to this random amount of time, so we don't even need this time module. And that means it's now going to wait before putting the item in the queue. And you might say, why is this not done anything? And the answer is because in a queue you actually can have a max size. So what we'll do is we'll say the max size is equal to 3. And we'll try again. And that means that it's gone through and it's been able to add. Because if we don't have this line here, then when we do it, and you might think, that's done nothing, it's just printed out the same things. But what we can instead do is we can set the block equal to false. So this means now if the queue is full, it's just going to try putting it in. And you see here, we get this queue.full error, because we put in a few things, and then it turns out the queue is full, and we're not blocking. So with blocking, imagine we've got this full queue and we want to put something in. So obviously there's no more space in this queue, so we have to wait. And if we use blocking, then we just stop and we wait for the queue to empty, and then we put something in. But if we don't use blocking, then we wait for the timeout to happen, and then when the timeout expires, we say, we've got an error, the queue's full, we've waited too long. And this is quite similar to the way that you empty it, in the sense that if it's empty, you can wait until something puts something in, and if it's still empty at the end of that point, then you just decide to leave it and raise the empty error. And so we could obviously get rid of this and simulate it in another way by waiting a second each time here. Or even 2 seconds, and then it's more likely to put this error in. And you see again, it's waiting, but the queue becomes full. But the other thread is still able to print out what's currently in the queue. So this could be really useful if you want some errors. And of course here it makes sense to try this and accept full, which we need to import. We can print queue is full, and we can leave this sleeping in for 2 seconds. And you can see it's full, and now it's going to go through each one and take it out. So we end up not getting any apples or bananas in our queue. So this queue has nice functionality that you can use it with other threads and worry about waiting, and you can either block or not depending on whether or not you want to put stuff in. The simple queue doesn't have a max size, and you can obviously set the max size here to a very large number. Usually a queue has a max size of 0, which means that its size is unlimited. But it turns out there are other types of queue. There's also a LIFO queue, and this has exactly the same architecture as this. It's just the order is different. So I'm actually going to take the simple queue example that we used to play with the LIFO queue. And this obviously we want to be a LIFO queue, and this to be a LIFO queue. And if we run this, you'll see that we've got true first, and then 5, and then A. And that's because LIFO stands for last in, first out, whereas before it was a first in, first out queue. So actually this is a lot like a stack. It just has these extra functionality features of being able to run across threads, which is what makes it in some ways more useful than a stack. So the LIFO queue is fairly simple when you understand queues. You just know that the order is going to be reversed. And if we did take this example and run it instead, if we set the max size to 0, so we don't have to worry about overflowing, and leave the time.sleep in here, maybe we just put in half second, making this queue a LIFO queue. And spelling LIFO correctly. You can see that the banana, orange and apple we'll put in last, and then true, 5 and A we'll put in first. And obviously that's we've got this one and this one. And if we decided to sleep a random amount of time, you can see that the order is quite different. So obviously orange and A have probably gone in first and last, but because we've got all this waiting, the one that's just gone in really varies. And so true and 5 are reverse order, but A's gone in first. And obviously there are some circumstances where you might want to use a LIFO queue. but it does have that feature of working backwards. Maybe you're coming up with a queuing system and you just think, people who have waited so long already aren't going to mind waiting longer, but people who don't wait very long will be really impressed by your service. Maybe you think a queue would be better for that. And then finally, we can have a look at a priority queue. And of course, it has exactly the same functionality as the others, except that the items need a priority. And here we'll also import random. And of course, we're going to need a priority queue, and we'll make our queue a priority queue. So the difference with a priority queue is if we try running this, you see that it doesn't support the comparison between int and string, and that's because you're meant to put in a tuple. So you put in your priority, which will be a random integer between, let's say, 0 and 5, and then your item. And you can see that it's gone 3, true, 3, 5, 4a, which isn't the order here. It's basically compared these values and said, this one's smaller. And obviously it said true is smaller than 5, so we could change our priorities so that they're, for example, just a random number. So maybe instead, we want to make this a random, so that if we get 2, we don't have to worry about them being compared. And so now, it's gone true and then a and then 5, because these are the priorities. And so what you tend to do is say that priority and your item are equal to queue.get. And so the priority is the first value, and the other one is the second value. So you then print priority and item, rather than having them as tuples. And you can see it works the same way. Another thing about priority queues is if you want to have these sorted the other way, rather than reversing them, you just put a negative sign in here, and then your priority is negative. So you can see it gets the smallest value, which is more negative first, and then all the others. So you can see a priority queue might be useful if you want to process higher priority things first, and then obviously it does all the comparisons. It also means that if you have some kind of data structure, you don't have to worry about sorting everything every time, because if you have a priority queue, they're automatically sorted as you insert an item, which is really useful. So as you can see, there's lots of functionality with queues in Python. They can be really useful, work between threads, and there are all these different variants that you can use them for. So hopefully you've enjoyed this video, you know how to use queues really well in Python, and I'll see you again, same time, next week. Till then.